All right, we're on to the last part of our third lecture. So this is part 3D. And man, we've been doing math. So we're going to do something a little different for this part. So we're going to talk about the difference between a chemical change and a physical change. So put away those calculators for a little bit. We'll be working on something else. All right, so let's get into it. So let me remind you from, I guess it was the first lecture, right? That we talked about chemistry is the study of matter, and we talked about study, right? That was like scientific method is the way chemists study. The study of matter. Oh, and we even talked about matter. Matter is anything around us that has mass and occupies space. And then we said it's the study of matter and the changes it undergoes. So I want to spend a couple more minutes talking about changes. How does matter change? Now, it turns out there's two ways matter can change. So some changes are called chemical changes and other ones are called physical changes. And that's what we're going to spend our time on in this part of our lecture. All right, so a chemical change is a process where a new substance is created. I'll say more about it in a minute, but let me go ahead and tell you what a physical change is. A physical change is a process where something might look a little different, but is really the same thing chemically. Really the same thing chemically. All right. So, that's an I. Chemically. There we go. That's an A. Chemically. Oh man, that's just too messy. Let's erase it and we'll write it again. It's really the same thing chemically. There we go. A little better, huh? All right. So, a chemical change, a process where a new substance is created. A physical change is a process where something might look a little different, but it's really the same thing chemically. So that's like kind of the dictionary definition, but let's talk about maybe a little bit more of like a practical definition. So one way you can tell these two things that happen in the world apart is chemical changes tend to be hard to reverse. Oh man, I'm messing up with my writing. It's never very good, I know, but even worse than normal. Hard to reverse. On the other hand, physical changes are easy to reverse. Now, let me also mention to you like why that is. So if you make something new, like a totally different thing, it's hard to go backwards. That's a chemical change. A physical change, you haven't really created a new substance. So if you haven't really made anything new, it's easy to kind of go back to what originally it looked like. All right, so let's look at a few examples. And actually, we've done some of these or talked about both of these in previous lessons. So like a chemical change, one example of a chemical change would be in the first video, I think it was again, I showed you that penny with the nitric acid, and you can see there's a photo of it there again, and it's turning it into a red gas and a green liquid. So a penny with nitric acid, that is a chemical change. And another example of a chemical change would be like rusting a car rusting. That's a chemical change. You know, you can't really turn the rust, the grayish red stuff or whatever that forms on the car back into a new car. So it's kind of hard to go backwards. Like that red stuff that forms, red crumbly stuff is a new substance. It's iron oxide to be exact. Okay, so those are chemical changes. Now a physical change would be something like, and actually we did one of these. Do you remember the one with the iron and the magnet? I showed you this on the video a little while ago or a few lessons ago. So you can separate iron and sulfur. Oh, let me put it over here, iron and sulfur with the magnet. All right, hopefully that rings a bell. So that's a physical change because I didn't really make anything new. I just took the iron out away from the sulfur, separating iron and sulfur, we'll say, with a magnet. If I wanted to, after I used the magnet, I could pour the iron back in and I'd have my original sample again, right? After I got the iron out, I could just throw it back in and back to where I started. Easy to reverse. Now, another example, last one I want to put up here would be also things like melting. So melting, like melting ice. Yeah, you can melt ice. But if you put that water back in the freezer, it'll freeze back again. So if you can go backwards, if like melting, you can refreeze things. That's a physical change. All right, with that, let's go ahead and move on to a few examples. So let me flip the slide here and let me give you a few to think about. All right, well, let's go over a couple of them. So all these are different things that might happen in the world. Are they chemical changes or physical changes? So a chemical change, hard to reverse. Physical change, easy to reverse. Milk sours. Can you turn bad milk into good milk? No. If you can't go backwards, that's a chemical change. I'll just put a C there. All right, cutting a pizza. Chemical or physical? Oh, wait a minute. That one, yeah, you can't, well, you can sort of go backwards, right? I guess you could sort of like melt it back together a little bit. Another way to think about it is, again, we didn't make anything new. So if you didn't really make anything new and you can kind of go backwards, that's physical. All right. Now there's two more on here. I'm going to pause for a minute. I'm going to let you work on these and see what you think about them. Then we'll go over them. All right, leaves turn brown in the winter. Can you make a dead leaf turn back into a brand new leaf? Nope. Chemical. All right. So dead things don't turn into alive things, right? There's no coming back from a dead leaf. It's going to stay a dead leaf. So it looks totally different. It's brown instead of green. You made new compounds when it died. It's a chemical change. All right. Water's poured into a cup. That one is physical. You could pour the water back to wherever it came from. You can go backwards. It's still water. That's physical. All right. So with that, let's move on to a few other terms in this last lecture. All right, so these terms sound kind of familiar. They sound kind of similar, I guess. So a chemical property and a physical property. So a property is like a characteristic, something that you know about an item. So some properties are chemical, some are physical. A chemical property is a property of a substance that has to do with how the substance interacts with other things. How the substance interacts with other things. So I could tell you, for example, silver reacts with acids. So how those two things interact, that's a property, a chemical property for silver. Or I could tell you gasoline is flammable. That's a chemical property. So the reason it's flammable is that really what that's telling me is that it interacts with air. So if it interacts with air and it catches on fire, that's a chemical property, I'm telling you. Similar one would be like iron rust. That again has to do with the fact that iron reacts with oxygen, and when the two react with each other, that property is a chemical property. Now, a physical property is a property that can be observed without changing the identity of the substance. So that sounds a little bit different. It basically has to do with not how things interact. So a property that has to do can be observed without changing the identity of the substance. For example, I could tell you like, oh, I just look at water. It doesn't have to do with how water interacts. I just look at water and I tell you water is a clear liquid. So that has nothing to do with how water interacts with other things. Or I could tell you Water boils at 100 degrees Celsius. That really has nothing to do with how water interacts with other things. So heat isn't really a thing, okay? So I'm talking about other kinds of matter. That's what I mean by a thing. So with that, there's two last terms I want to mention, and those are on the last page here. Let me flip over. Okay, for our last few terms, I had to bring in an assistant. This is my daughter. What's your name?
Eliza.
Eliza. Okay, Eliza, I want to show you a little demonstration, and we're going to see what we call this sort of process. So what I'm going to get first off is just a little vial, and in here I'm going to put some good old water. And I'm just going to pour a little water in real quick. And then into it, I'm going to add some Drano. So Drano is actually like, use it to clean your pipes at home, maybe if you have a plumbing problem. And it's really sodium hydroxide is the real name of Drano. So let me go ahead and grab a little bit. And I got a glove on because I don't want to touch it. You never want to touch it because it can burn your skin. And let me put a little Drano in, sodium hydroxide really. Uh-oh, I dropped one. Better pick that up after this. All right. Oh, I dropped another one. Wah! Okay, we'll get those in a minute.
You dropped
All right.
4.
4. Oh my God, what a mess. All right. So I'm going to put it in water, and then I'm going to shake it for a little bit. All right. And then what I want you to do, Eliza, is, I know, well, they're down there. Don't worry, we'll get it. Don't step on it. Here, I'll pick it up right now so you're not too worried. All right, we'll put it, I'll put it right here. All right. And what I want you to do, Eliza, is, let me shake it just a bit more. And go ahead and touch it. And what does it feel like?
It feels warm.
It feels warm. That's right. It feels warm. So a process that feels warm, there's a name for that. Oh, feel the bottom. Feel how hot the bottom got.
Whoa.
Whoa, really hot, huh? That's called being exothermic. Wow, it's like burning hot, isn't it? So exothermic is a reaction that that gives off energy. So this is one of the ways Drano works, actually, is that when you put it down your pipes, it warms up, and if there's like gunk in the pipes, it'll make the gunk start to move because it'll like warm it up and it'll start flowing a little better. All right, thank you, Assistant Eliza. So you can go ahead and step.
I didn't do anything.
Yes, you did. You told them that it got hot. They wouldn't believe me. All right, so with that.
Are you sure about that?
I am sure about that. All right, I need my next assistant. And my next assistant is my other daughter, which is Abby. All right, Abby, come up here. And I don't know if you really need the box. So, all right, be careful where you step, though, because I did drop a couple pellets of Drano. We don't want to step on those. All right, and I'm going to do another demonstration. Actually, for this one, I don't really need a glove on, okay? So for this one, I'm going to mix two solids together. This one is called barium hydroxide, and then this one's called ammonium nitrate. All right, so I'm going to mix the two together. Now, before I do that, Abby, I'm going to get a piece of cardboard, and I'm going to put a little water on it because I don't want it to hurt the cardboard. So I just want to put a little water down, okay? That's all right. We'll have a little water. Maybe I'll put a little bit more. Okay. All right, now let me point it down a little bit. All right. There we go. Can you see the cardboard? There we go. Almost. This is oh. Oh, we're learning how to teach online, aren't we? Okay, there's the cardboard. All right, now I'm going to mix the two together in this beaker. So it's barium hydroxide and ammonium nitrate. So let me put one into the other. I think you guys can see this. If not, my lovely assistant will tell you what's happening. And I'm going to just stir them together, okay? So this one takes a little while. Maybe we should move this back so it's not blocking the way. And then I can move this over a little bit. There we go. Maybe that's a little better view. All right. Oh, first off, do you notice it stinks? You smell anything?
Yeah.
Yeah. It smells like, does it smell like cleaners we have around the house?
Yeah.
Yeah. It's because it's actually making, you don't smell anything. It's because it's making ammonia. Ammonia is what's found in cleaners. Woo, I'm smelling it. Yeah. All right. Don't worry. It's not going to hurt you or anything.
I know.
All right, I'm going to turn on this fan just to get a little more air because it's, ooh, it is stinking. Oh, don't worry about it though, guys. I promise I'm not going to kill you. All right.
We know that.
You know that. Good. You trust your father. That's always a good thing. All right, guys, it's about done. All right, so we made some ammonia. And now, let me just let it sit for a minute. Okay, you about ready? All right, now I need Abby. Abby, I'm going to pick this up and I'm going to hand you the beaker, okay? So you ready? I'm going to pick up and I'm going to hand you the beaker. Are you ready? You want to grab the beaker? We'll feel it. Okay, I'm going to pick it up and... Whoa. Do you see that? What happened, Abby?
It's like sticking to the cardboard.
It's like sticking to the cardboard. So why do you think it's stuck to the cardboard? Do you have any idea? Why don't you feel the beaker?
It's cold.
It's cold,
Oh,
and
did the water like freeze?
that's exactly what happened. You're so smart, my smart 11-year-old. So the water froze, and it made the beaker stick to the cardboard. So this one got cold, and it got really cold. So a process that gets cold is called endothermic. So this is an endothermic reaction. All right, it's really cold, huh? All right, well, thank you, girls. And I am going to write a few notes on the screen here for my students. All right, so we saw a process. Be careful you step out that way. All right, I need to get back over here. And let's just take a couple of notes here. All right, so processes. Some processes are exothermic. So exothermic, oh, Eliza can stick around if she wants. Let me point this. All right, exothermic is just a process that gets hot. Another way of saying that is it gives off energy. That was like the Drano with water. Now, endothermic process, it gets cold. When it gets cold, my daughters have lost interest, that's okay. It gets cold. Another way of saying that is it absorbs energy. Absorbs energy. And that would be like the demonstration with the ammonium nitrate. Okay. Yeah, they're gone. They had enough chemistry for today. I hope you haven't. All right. So with that, those are two examples there. My message writing, I hope it didn't get to you. I had to write a little weird because I had to move the camera. All right. With that, we're done with the third lecture. Yay! Onward!